Hi guys, I would like to first of all review the implicit differentiation that was covered back in Calculus 1. So back in that time, we have, say, suppose this is a equation of a circle. This is not a function because it fails the vertical line test, right? Because this equation, it doesn't pass vertical line test. In order for us to find the dy dx, there are a couple ways. Method number one is you solve for y and then find the derivative with respect to x. So which means like y equals plus or minus 1 minus x squared, and you find the derivative based on this one, but obviously we have to do it twice because there's a plus or minus. Another method was back in that time, we introduced the implicit differentiation. So how do you find that? You treat y as a function of x. Okay, so back in that time, we say, okay, now we differentiate both sides with respect to x. So here you get 2x plus. Now when you find the derivative of y, you gotta use chain rule. So it's gonna be 2 times y because it's power 2. So 2y. Now times the inner function, which is dy dx, and then equals 0, and then you solve for dy dx, and then this is called which is equal to negative x over y, actually negative x over y. So this is called implicit differentiation for one variable case. So you treat y as a function of x, even though you see 2 variables, but actually you treat y as a function of x. So this is still belong to one variable calculus. So for today, for this particular one, we actually want to look at it in a different angle. You still get the same idea. For instance, if you use what you learned previously, you can solve this problem using the technique that we just described. Now we just want to look at it differently. Okay, so let's read through that. Suppose f of xy equals 0 defines y implicitly as a differentiable function of x. Now here's the one example. So here y is implicitly defined by this equation, and this equation can be written as this form, f of xy. So we move all the non-zero terms on one side and leave 0 on the other side. Now here we have a function on the left side, and when we set to equal to 0, we have an equation. On the left side, this is a function in 2 variables, right? There are 2 variables. One is x, the other one is y. So now we can, so in other words, usually when I have that, I can draw a diagram, right? F depends on x and f depends on y. Okay, now here's the trick. You think of x depends on x and y depends on x. That's the trick right here. And then when you do that, if you remember that when we write this diagram, we use partial derivative when we have more than one branch, right? So therefore you get this, del f del y. Here you have del f del x. Now the next layer, because y only depends on x, I'm going to use dy dx. Here this obviously dx dx, which is just 1 basically. So when I find the derivative for this function with respect to x, you see I have 2 branches. So therefore, according to the chain rule that we described, this chain rule says when we find the derivative with respect to x for this guy, it should be del f del x times dx dx. That's the first branch, plus del f del y times dy dx. This is the second branch, right? Okay, so this is what we have right here. So this is what we have right here. And the right hand side, because it's constant, the derivative with respect to x is just 0. And then let's solve from here. Let's solve for dy dx. So when you solve for dy dx, it's gonna be, this is just 1, this is just 1. So so here this means fx, this means fy. So therefore your dy dx, after you do this algebra, is going to be equal to negative fx over fy. So this is the new formula derived from a different perspective. So this is the implicit differentiation formula. Let's try to apply it for the next problem here. So let's do it in next problem. Okay, so according to this formula, I just need to find fx here first, which means here you treat y as constant when you do that. So x is variable. So the first one will be cosine xy, right? Derivative of outer is cosine u, so cosine xy times derivative of inner times the derivative of xy with respect to x. So therefore you are left with y because y is constant. Plus the second one will be 0, right? Pi y square, it's going to be 0 with respect to x. So minus 1. Or you can just write this as y cosine xy minus 1. So this is fx. We still need fy. So according to, again, this partial derivative, you treat x as constant. So therefore you have x cosine xy. And the next one will be minus plus 2 pi y. And that's it. So therefore dy dx should be equal to negative fx over fy. So negative of fx is going to be y cosine xy minus 1. And the bottom is x cosine xy plus 2 pi y. So this is it. Now, how would you do this same problem if you were now in Calc 1? So this is how you could do it. I strongly advise you to compare those. It's more valuable to know different ways to solve a problem. That will give you different. Just look at the same thing from different angle. So in the past, when we find that you treat y as a function of x, right? So you still think of this as your inner function u. So it's going to be cosine u x y times, okay, you find the derivative of the inner. I'm going to write one more step, dx dxy dx plus, okay, the next one should be easy. It's going to be 2 pi y times, okay, you gotta treat y as inner function, okay, so y prime, okay, and then minus 1. So minus 1 equals, the right hand side is just 0. So here the reason I do this separately, because we have two functions, x and y. Y is a function of x, so we gotta use products rule. So it's gonna be cosine xy times, okay, products rule, the derivative of x is just 1 times the y plus x times the derivative of y, which is y prime, right? Plus 2 pi y prime. Minus 1 equals 0. And then at the end, you just need to solve for y prime. So let's quickly solve that. So y prime is right here. We need to isolate these two terms. So cosine xy times y plus xy prime times cosine xy. What am I doing? I'm just dropping this parenthesis. And then plus 2 pi y prime minus 1 equals 0. So I'm going to leave all these terms on one side. So which is y cosine xy minus 1 equals and I'm leaving all these terms to the other side. By the way, I can actually factor out y prime, right? So it's going to be negative. So I'm factoring y prime. X cosine xy plus 2 pi y. Okay, at the end, I should divide both sides by this term. And of course, also remove the negative sign. So y prime equals negative y cosine xy minus 1 divided by x cosine xy plus 2 pi y. So I just want you to compare these two. You probably feel that it's pretty nice to go with the first method because it's less complicated if you compare these two. Hopefully you agree with that. Okay, so the very last one, let's quickly solve the next one. I'm pretty sure that you would be able to solve that, and so you probably want to pause the video and just do that yourself. But I'm gonna continue to solve that. Fx is gonna be 3x squared plus, oh, by the way, we should rewrite this as 0, right? Okay, so rewrite that. So therefore 3y squared, and then Fy will be 6xy minus 5y to the 4th. So dy dx will be equal to negative fx over fy, which is 3x squared plus 3y squared divided by 6xy minus 5y to the 4th. And I strongly encourage you to try to solve it using what you like, the implicit differentiation from Calc 1. Just like what you do there, you should compare.